Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super, and today's incident we're going to focus affected Azure Data Factory and EastUS2 on the 6th of March. Now, customers would have experienced pipeline execution delays. After a recent service update, it introduced a change in an internal response handling, which, when you combine this with the scale of EastUS2 and a backlog of deleted resources, led to problems for our customers.
That's right. So to talk us through the impact and our learnings, I'd like to introduce the engineering leader joining us as our guest today. On my right-hand side, Mario Zimmerman. Mario is our partner and software engineering manager from the Azure Data Factory team. Thank you for joining us, Mario.
And of course, never great to be here talking about an outage, but hopefully out of this, people understand a bit more how things work and also, trust the service.
Very good.
This won't happen again.
Super. Matt, before we get to the incident itself at all, the number one cause of outages in our industry is change. And so I know that Microsoft is very diligent about how we make changes. So we use safe deployment practices where we deploy a change and then after it's all clear and there's no bad monitoring, it keeps expanding. We don't update zones at the same time or region pairs at the same time. And so could you talk us through a little bit about how Azure Data Factory leverages safe deployment and what happens on a good day when there's bad code or bad config changes, both of which kind of go through the safe deployment philosophy?
Of course. I think at Microsoft on Azure, we understand how customers rely on us for their production workloads, right? So any type of outage is a bad outage, it's impact, right? But regressions, outages caused by change, are particularly hard, and I want to go a little bit into that, right? I think as Azure service, we build on top of each other, right? So when we're doing that, we always have resilience. I think one of the most well-known projects that we did recently was the availability zones, where even if a full data center goes down, we are still resilient to that, right? So that's not the only way that we do resilience. If you're building on top of Cosmos DB, storage accounts, you always have resilience, right? When a service introduces a change and it breaks production, all that resilience story goes away. So outages caused by change are the worst types. The impact goes across all services and impacts multiple customers, right? So there are several different initiatives to avoid outages, and particularly to avoid outages caused by change. Two of them I want to mention here. One of them you just brought up, SDP, and this is a critical one, right? We obviously want to catch any kind of regression as early as possible. It's what we call shift left. We want to make sure the engineer is not writing that bug to begin with. If we cannot catch it there, at least let's catch it in a code review time. Right? There's all of that, right? But we are not going to be perfect, unfortunately, right? So the idea here of SDP is there's a sequence of practices here to avoid and reduce and detect customer impact as early as possible, right? So one of the critical things here is we're always deploying to Canary first, followed by a pilot region, and then we do one small region, one medium region. There's a sequence of we never deploy those changes globally right away, right? And the idea is the earliest you can detect that, the better, the less customer impact. It's not just that, right? Every time we're deploying, we're also running fully automated tests with alerts that will catch those issues automatically, right? When an issue is detected, outage is declared, the deployment stops, it prevents it from going to other regions and increasing impact. And we'll talk about this later, right? Even automatically rolling back if there's an issue here that was detected, we know that's customer impacted, right? I do want to bring up a second initiative here that's been it's somewhat recent, last year or so, but it's also very focused on avoiding regressions, and it's what we call ready to deploy, R2D, right? And the idea is that every single change that happens in production should be discussed and evaluated at different levels here, not only at the engineering level, but going from an engineering director to potentially a CVP, depending on the risk of that change, right? And it's not we're going to, again, review the code. That process has happened already, right? But we do want to understand every change that's going to production, what's the risk, and what can we do to reduce that risk. So I'll give you one example, right? Let's say we're making an authentication change, a cross-service communication change, right? If something like that goes wrong, the impact here is going to be broad. It's not going to be limited to a corner case feature that maybe a couple of customers are using, right? This is something that will impact everyone. Something like that, we want to be even more careful, right? So maybe as part of that R2D, the conversation that will happen is like, how can we proactively confirm, like have a positive confirmation that things are working, right? Make sure you have a rollback story ready and tested in case something goes wrong, right? Like, how do we guarantee that this is working? We can't avoid, we cannot, I'm not gonna do risk changes as part of the service evolving, but every time we do them, we wanna make sure that we have a quick way to detect and mitigate quickly so that we avoid customer impact. Mm-hmm.
That's cool to understand. So but from both a safe deployment, SDP perspective, and from a ready to deploy, R2D perspective, the whole point is being cautious, making changes slowly, being able to catch that as early as possible. So that's cool to understand. I know that'll be an important part of our story. I wanted to check that the PIR mentioned lifecycle management. And before we even get to the specifics of the outage itself, what we're talking about is these inactive or deleted resources.
Yes.
And I think it was a surprise to me that when a customer says, go and delete this thing, we don't necessarily delete it right away, but there's some kind of asynchronous process that goes around and cleans that up later. Could you help us to understand that a little bit and why we chose to do it that way? What were some of the trade-offs involved there?
Yeah, so bear with me a little bit on the technical details on this one, right?
Sure.
And I think overall, when we're talking about design good APIs, there's a couple of principles that we need to follow, right? And one of the most critical ones is that it needs to be transactional. What I mean by that, let's think about delete data factory as an example, right? Ideally, the API succeeds. And when it succeeds, it does what it's meant to do. It deletes our factory. And the key here is it does what it's supposed to do from a customer perspective, right? So after a factory is deleted, that name needs to be released, and the customer can use that to create a new factory if they want to. There can be no more billing events for that factory and all of that, right? No pipeline should be running on that factory, right? So the operation succeeded as expected, right? In the scenario where the operation fails, maybe it's a user error or it's a system error, it doesn't matter, right? It's very important that the state of the system remains how it was before, right? So we shouldn't be in a situation where, we failed their API, but half of the resources were deleted, half of not. That's a bad design, right? One of the common misunderstandings in the industry around this is that a lot of times we use long-running asynchronous tool calls to solve the problem. That's a mistake. It doesn't solve the transaction needs, right? Tools are meant to be used for long-running operations, not to enforce that this is a transaction, right? So what do we do here? We want to do the right thing, right? We follow a pattern here called lazy deletion, right? So we separate the customer experience from the true needs of the operation, right? So in a synchronous way, in milliseconds, we respond to the customer with an, done. And what we are doing at this point is marking that factory as deleted. From a customer perspective, this is gone. Like I said, name release, no more billing, no anything, right? But we didn't really delete a lot, everything yet, right? Everything lives in the background. And it's completely transparent to customers. It's our problem now, our cost, right? But we do need to delete those resources at some point, right? And obviously, deleting those resources also puts pressure on the service, right? So we want to make sure that we do that whenever the service is maybe not overloaded, right? We can do that at any point in time. It's just cost for us, right? That's where those resources come from. In this particular case, we had a problem where some of those resources were not deleted when they should, and they accumulated. But overall, the idea of lazy deletion is a good thing, meant to actually create a better experience for the customer here.
Super. That's really, and again, for customers, as far as when they hit delete, as far as they're concerned, it's all gone. We're just dealing with some of that debt in the background.
Yeah. And that type of methodology to do operations is actually hard on us. It's more complicated to do that than to just do a tool-to operation that maybe would take 20 minutes and complete, right? But we do believe it's a better customer experience. We don't want a customer waiting for 20 minutes for something to be deleted and billing to stop and then to be released, right? We want to give that immediate response saying, you asked me to do something, I did it for you. Let me handle my trash myself on the side. You don't need to worry about that.
So this is fascinating, because if we fast forward to the 6th of March now, your deployment had, I assume, been going for some time, and you've been getting checks and green marks, and once you get the traffic light for green, it goes to another deployment, another cluster. But then we reach EastUS2.
Yes.
And in EastUS2 now, with a combination of this and EastUS2, we run into a wall, and then customers started getting these pipeline execution delay. Could you walk us through a little bit about what customer pain would have felt like once we hit EastUS2?
Yes. And I think the first thing when we talk about customer pain here, like, one acknowledge that this was terrible. Like, I don't actually remember the last time we had an outage this bad in Data Factory, but it isn't something that happens often. And like, the overall time for the outage was around like 6-7 hours, right? It's not like customers were impacted that entire time, right? Like, but yes, there are some unlucky customers that like started to see impact right away and like went all the way to the end, right? So fully acknowledge that this is very painful, right? With that in mind, I do want to talk a little bit about some of the trade-offs that we do on ADF, right? And how do we try to, in a world of like a bad place because you're having an outage, how can we make that a little bit better, right? So one of the key principles that we have here that we try to enforce is when an outage is done, when something like this happens, an outage is done, we want the customers to be fully recovered right away without any manual actions from them, right? So what we try to do is we try to have enough retries here so that your activities are delayed but not failing, right? And I understand that this isn't enough. I'm not proposing this as a solution, right? But what I am saying is that like for some of our customers, that might be good enough. If you have a daily pipeline that you want to make sure that it completes, maybe it was delayed by a few minutes, that's okay. Very unlikely it's going to be okay to be delayed by 6 hours, right? But if it's a few minutes and we recover all of that and we ran it automatically for you, maybe that's okay, right? For some customers, it's not, and I understand that, right? But we are trying to like address as much as possible, right? And I think like in a world of bad experiences, I think the worst thing is like after a 7-hour outage, right? We are having customers here that are gonna have to like manually identify what has failed, what do I need to rerun, what was like, like the cadence for those pipelines. Let me figure out, like, spend another like few hours trying to recover that state, right?
Just a follow-up question. Was this every customer in EastUS2 who was running Azure Data Factory?
It was not.
Okay.
I think as it's almost always the case with outages like this, the service is not down, right? But the service is overwhelmed in this case, for example, right? So we have competing activities trying to run here, right? Even someone, for example, that started to see that impact right in the beginning, right? Their activity probably succeed at some point, like after that, right? And the same way, like pipelines that were starting 3 hours in, 4 hours into the outage, right? Like they might get impacted right away, or they might not even get impacted. They might run. They might be the lucky ones that are going through, right? But throughout that time, it's unlucky if you got 7 hours of delays. There's a variation here how much delay you did get, right? I want to add 1 second design decision that we have on our side that translates into customer impact in something like this as well, right? We obviously understand that customer needs to be able to interact with the service, create new pipelines, stop or start pipelines. Like there's a set of CRUD operations here they might need to do, right? In a scenario like this, where we're having an outage, where service is unavailable, right? We also do prioritize your production pipelines. Like whatever you currently have running in production, we do make the assumption that you need those workloads to run. You depend on those, right? I understand that creating new ones is important for you and all of that, right? But if we have to choose, we will prioritize the ones that are currently in production as opposed to your ability to create new ones, right? And that's why in this outage, some customers might also have experienced like the inability to make like API calls and create new things, right? It got to a point where we needed to prioritize what's already in prod versus creating new things.
Right. It's helpful to understand that the different layers of that degradation, that it wasn't hard down, that for some customers this was intermittent. And I want to emphasize that key point that you've made is for a lot of customers, this was latency. There were some errors, there were some failures of it timed out eventually, but most of the time it was just these delays. One thing that we didn't quite get to is in the context of safe deployment, where we started, in the context of making these changes carefully and slowly across regions, this change that we're talking about had already rolled out to dozens of regions, almost all regions, but when it got to EastUS2, something was different. What was different about EastUS2 that we didn't catch earlier, right?
Let's talk about the 2 initiatives we brought up here, like SDP and R2D, right? And they are meant to prevent outages and regressions, and this is an outage caused by a regression. How did this happen, right? I think from even R2D point of view, right? Like, the change that we were making was simply changing the return code of one API from 500 to 403. It seemed safe. Even knowing what I know right now, even knowing the outage that it caused, I think I would still evaluate that as safe. So it's one of those cases where it was hard to foresee what was going to happen, right? And I think like part of that is also the impact that it had on SDP, right? We did deploy to 36 regions where we had like 0 customer impact.
Right.
And I mean we had 0 failures there, right? And what happened here in EastUS2, right? I think it's that combination of going back to our delete operation and the lazy deletion, right? We did have a lot of resources here that we had like lost track of. And they have 0 customer impact. So it wasn't a problem for the customer. The fact that they were there is actually cost for us, which is not great, right? But we had a lot of them, right? So this specific change that should have been like extremely harmless, in conjunction with the fact that we had like all those like lost resources, plus with the state of the region, it is a big region. We have like only so much we can scale out automatically, right? It led to this impact, right? So it is. It's not an excuse. It shouldn't happen, but it is something that and again, reinforcing the SDP and all of that, right? Like we still had a few regions to go after this one, including some like European regions, right? And SDP did help us there. We did stop the cycle and we didn't go forward, right? So it's hard to use that as an argument for the customers that were impacted, but we did prevent impact from spreading out even further.
That's really cool to understand. That's not justifying anything that happened, but it's certainly explaining what happened to understand that. And what I'm hearing is it's part of the reason we try not to talk about a root cause, a single root cause of anything, because you're talking about these combining factors here. It was the specifics of the size and load of EastUS2 combined with this unique backlog that had accumulated, and safe deployment, is still some value in it.
And adding to that, right? Like I think Azure overall, and certainly Data Factory, we are at a level of maturity here where single factors don't cause this type of outage, right? We do have a lot of things in practice to prevent those like single failures, right? We are not yet at a point where we can prevent those like multiple factors coming together. We didn't think about that. And we are investing in that and making progress there. Sure. But like, as you see on this outage, they still happen from time to time. Ideally, like, less and less going forward.
I do find it interesting because in theory, safe deployment is wonderful. And every time we put something into practice, we find these really unique edge cases, whether it's region configurations, which typically shouldn't, but in reality, where the rubber meets the road, our cloud has interesting components we need to factor in, and as our safe deployment methodology advances. I wanted to talk a little bit about detection. As you said, these were delays. And so how do you go about investigating execution delays? They weren't failures. Could you talk us through about how we detected this and then how we investigated it and ultimately how we mitigated this?
Yes. So one of the things when we go back to SDP and we're talking about like how we automatically run tests and like validate the change before we go to another region, right? In this case, even in the region where we had impact, we actually caught that we were having problems before customers were impacted, right? So we knew that the service was behaving weirdly in the region where impact happened, right? And we got the DRI on the call, we got the AM on the call, I also got called, right?
I'll help to translate DRI, directly responsible individual, incident manager, all of the on-call folks.
Yes, and the intent here, right, with the methodology that we have is we still have a chance. We know that something is going bad. Let's get folks involved. Let's prevent this from being customer impacting.
So that's from a detection perspective, tech. We were on top of it.
Exactly. So we were on the bridge. We're all trying to solve this. And one extra thing I'll add to this, right? We knew we had just deployed, and we knew that like a problem was, brewing, potentially going to have been customer impacting, right?
So we'd correlated it early. We assumed that was related to the recent change.
And what we do in that case is like we roll back the change. Like, and the model is don't think rollback, right? And we do build our services in ways to support that, right? So it did take us a bit longer to do. It wasn't a fully automated process. So like even though we did the right mitigation, was rolling back, we couldn't do it fast enough, which in the end translated to impact.
Got it, but that's really good to understand that it wasn't a detection gap. We knew about it, we were on top of it, we correlated it to the change, we were already applying mitigation, it just wasn't, we weren't able to mitigate it quickly enough.
And it's key here, right? Like we didn't know what the problem was. We didn't know the root cause, right?
We don't have root causes, right?
Contributing factors.
And it might not even have been like deployment related, and like we actually had that doubt, right? Because like this doesn't look like it's like change related because we deployed to 36 regions and nothing happened, right? But still, even in a situation like that, right? Like if there's even the chance that it is caused by change, roll back. If it's not, we roll forward again, right? It's okay, right? But like do what you can right now and then investigate, which is kind of what we did here, but it was still a bit more manual than I would have liked.
I like that. Don't think, roll back.
Yeah, don't think roll back. And do you roll back the region, or do you roll back the whole deployment going back?
We did roll back only for this region.
Okay.
But again, at the same time, we were watching the other regions and seeing like, did something happen here? But again, with the whole SDP, the time between region deployments is actually 1 day, right? So for the 36 regions we are talking about, they have been held for like some of them 4 days.
Okay.
So we didn't feel like rolling back that would make sense. But again, once we did understand that it was indeed a regression, we did roll back everywhere. Right? So we hot fixed it actually, but yeah.
All right. If we pivot to learning and repairs,
Yes.
we had two. When I was reading through them, some of them are very elaborate. The obvious ones that I remember calling out is number one, we've cleaned up this backlog of these resources, and the other one was around we've conducted an audit around all of our regions in Azure, and we're going to delete those things. Are those two still on track? Is that
Yes, the deletion of resources is an important one, right? And it's more like it's something that was hard for us to predict that it would have impact. And we don't want to be in that situation, right? When we are like evaluating the risk for changes on RGD and all of that, right? Like we don't want to be thinking we have like millions of resources sitting here that we don't have like a hold on, right? Like, that's a bad state to be in. So we cleaned that up, right? I do want to go back to your question about like, hey, we have RGD, we have SDP, yet we didn't detect, and how can we improve that? And that's one of the critical repair items for us, right? I think we are at a new place in engineering, in the industry, but we have like more resources to do analysis that we didn't have before, right? Like up until, I don't know, a year ago or so, right? Understanding impact here was limited to, I'm creating this we have like this pre-created queries, we're looking at specific signals, right? Or maybe we even have like a human that's going to look at the logs, right? And those things work, but to a point. In this case, it didn't, right? So, but we are not in that place anymore today, right? Now we can go to AI and say, look broadly on my region. Do you see anything that looks suspicious, right? And we cannot get that level of consistency from a human, but we can get that from AI, right? And moreover, right, like we can go and say, I deployed to 36 regions, it didn't happen there, but like, do you see anything that correlates region by region as you're going forward, right? Like there's something we didn't have in this case, right? But we built as a repair item for this. And we went back and we looked on the 36 deployments, the successful deployments that we had, right? And we do see signals, right? Again, it's zero failures. It's zero
signals is not customer impact.
It's not. Yeah. It's not. There are no failures, no customer impact, but we do see a small increasing load right after deployment. And it is something that, like, depending on the region, a few minutes, a few hours, it goes down, and we just handle that, right? Like, but this is the type of thing that we were not deploying a change that should lead to increasing load, right? Like, that's weird. So let's stop. And in a case like this, it was extremely consistent across the regions, right? So we would absolutely have stopped if we had a solution like this before, right? So this is already in production, we're already using this. Of course, we're gonna continue to improve that solution, but this is one of the key repair items here. Going back to your question, right? Like, all our initiatives here to prevent regressions didn't work. We need to be better, and this is one of being better about it.
Yeah, that's great that on the detection piece, with the benefit of hindsight and with the power of AI, hey, turns out there were some of these anomalies, and that can now inform kind of the future decisions. That's great on detection. Now, what about mitigation?
Yes.
Because as we were just talking about, we were on top of it, we were trying to mitigate it, but that was happening slowly. Now, we mentioned one of the repairs was upgrading our deployment tooling or our deployment systems so that the systems can automatically roll back without needing humans. What does that look like?
Yes. So most of the times, the process that we have today, the don't think rollback, works. Particularly works because, again, we get on the bridge, right? We get to handle this before we have customer impact. We have those proactive alerts, right? So we had some time here to fix this before impact had happened, right? And if you spend a few minutes here, usually it's good enough to prevent impact. In this case, it wasn't, right? And the time that we lost here is like, you call someone and say, hey, there's a problem happening here, right? The person gets on their computer, joins the bridge, and then we start the rollback manually. And ultimately, in this case, it took us half an hour to trigger that, right? It's usually more than enough to prevent impact, and even when it isn't, there's a few minutes, like 30 minutes here might correlate to 30 minutes of impact date, which is bad, but that's where we are, right? In this case, it was worse. In this case, every minute that we delayed the rollback meant hours of impact in the end, right? What we want to do here, and it's already in progress, is like automatic rollback. We know to stop. We know to do an automatic stop. We need to do an automatic rollback. And I'll go even one more layer of details on this, right? A lot of times we think as rollback as like redeploy the previous beats. That wouldn't have been good enough. That takes too long, right? But we have developed a way to do like a very quick rollback of our service here. We can roll back in minutes, right? So the key here is like, let's trigger the automatic rollback as soon as we detect something. If it happens to be nothing, we roll forward, right? It don't matter, but we cannot afford to risk having this type of impact.
This is fascinating because particularly with the signal to noise ratio and rolling back, and I know that you're not the only service that deploys updates. So when you have 200 services on Azure all deploying updates and there's a lot of interdependencies, plus you have signal to noise ratios and an automatic rollback, I can see why the timeline is December. It's a very complex problem to solve. If I can pivot now, we know what Azure Data Factory and Mario and team are doing to make things better. If I look towards our customers, we included documentation in our PIR that said customers who were looking, there was a backup and recovery option for Azure Data Factory. When I think about PaaS services running in the cloud, if something is mission critical, they can run this in active in 2 geos, which I know is expensive at times, but I didn't see that as an explicit option. And we spoke about this backup and recovery. What could customers have done to be immune to this type of outage?
Yes, and there are different layers of needs here from different customers, right? For customers that are okay with a little bit of latency, I wouldn't say 7 hours. We should never be in this case, right? But if you're okay with like latency in the realm of like minutes, right? The first recommendation I would give is don't put a very short timeout on your activities, right? Do put retries there. We will do everything we can to make sure that all you see are delays, no failures, right? What that means is like most likely we can recover from a problem here without you even being impacted, without even like perceiving that impact, right? And everything will go back to working the way that you had before without you having to take any action, right? This isn't good enough for everyone. Some of our customers here need like, even minute delays are too bad, right? And something like this, like 7 hours, is unacceptable, obviously, right? So we do have a customer-driven disaster recovery document that's out, right? That can be a live scenario. That can be like a active, passive scenario, right? Where you can like automatically trigger the recovery. Those are not simple architectures, right? And by no means I'm trying to move, this problem away from Azure supposed to guarantee the execution and like a quality of service that we promise to our customers. Like this is our responsibility, and we're constantly making improvements here, right? At the same time, there are things that customer can do for when we fail, right? The document is out, and what I always recommend to customers is, I don't want you to try to read this document and implement this when an outage is happening. It's not going to work. It's not that simple, right? So go through that like beforehand. Have your infrastructure set up, right? We have a lot of customers that actually were successful in doing the recovery, moving to the paired region, which goes back to our SDP policy, right? We never deploy to paired regions in the same day, right? In the same tier, right? So when something like this happens and we have a regression on the tiers, your paired region is going to be healthy, right? So you can do your disaster recovery to the other region.
I'm glad you mentioned that, hey, there's additional cost, there's additional complexity, this isn't right for everyone. But as Sammy said, if this were really mission critical, there are options available to you. I think that's great to understand, and obviously retry logic, things like that, always important. Thank you for understanding, for running us through kind of the learnings from ADF side and maybe some of the learnings from customer side. I saved my last question for Sammy. Sammy runs our incident communications team. How did we do on comms here?
This was interesting. So for customers, there was, as Mario said, they detected pretty early, they investigated quite early. There was one piece, when engineers are called in to try and mitigate something, when the heat is on and the pressure is on, they started mitigating, which is what Mario and team did on the day. Our tooling and we have systems built on systems. So unless the engineer declares that there is an outage going on, there's delays in communications and all the right people showing up. And this is what happened here. There was a little bit of an extended delay. The additional pieces, as Mario mentioned, because there was latency and it wasn't failures. Typically, we have across Azure, the vast majority of our outages have this kind of auto communication from our brain system, which is pretty rudimentary, but it says, hey, it's an Azure problem, not a customer problem. And because it was latency and not failures, and because of all the kind of complexity that Mario touched on, we didn't have that either. So even when the comms team were brought in afterwards, because the box was checked, even then for the engineer to not have those automatically to hand, took time out. And so there's a trade-off of, do I mitigate or do we let people know? And of course, we want to let people know, sometimes even at the cost of mitigation. But given everything there was a delay in communication. When we look at these types of failures where more humans are needed than systems, we've been tackling this problem for a while. We use things like Brain, which is wonderful just to get a flag in the ground and highlights customers. But every time we come across these edge scenarios, it's another area we need to go and invest and double down in and make sure that we make these less and less. We're making progress, which is great, but every time they come up, it's painful for us, it's painful for our customers. So yeah, we have some learnings there.
Right, so more investment in AI and Brain scenarios, but I'm glad that you mentioned, hey, even if the communications were a little delayed, it's not because we were asleep at the wheel, it's because we were busy mitigating
Absolutely. And it shouldn't be on the engineer to go and think, like, I need to check this box and turn this dial to make sure these things happen.
They're busy fixing it.
They should be busy fixing it, and our system should do this. And typically they do, but we found edge cases where they don't because of these class of failures, which we're closing the gap on.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure Well-Architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.